Hey, everybody. Yes, so I was going to come in and totally blow your mind and mention that React can target things other than the DOM. And yeah, thanks, Christopher. That's great. Well, today I'm going to talk to you about React beyond the DOM, but we're actually going to go into a little more technical detail than Christopher did, and we're actually going to take a look at some of React's extensibility points. So first of all, a little bit about me. I'm the cross-team tech lead for the Netflix UIs. I'm the architect of Netflix's UI data platform, and I'm a member of the TC39. So for those who don't know, it's the JavaScript Standards Committee, and so we're helping shepherd some of the cool ES6 features that you guys saw today. Yeah, so this is the story of how Netflix pushed React into places where the DOM could not go. And specifically, I'm talking about things like embedded devices. So before we start, though, 3 things you guys may not know about Netflix. First, we love JavaScript. We use JavaScript everywhere, and there's a lot of reasons for that. The first is that Netflix runs on thousands of devices. We want to be wherever you are and whatever device you're using, whether it's in your pocket, in your hand, or a hologram, or which we've all seen recently. We want to be there. And JavaScript gives us that reach. It gives us the ability to reach all of these devices. Another thing that's really key to the way Netflix works is we think constantly about how to improve your UX experience, how we can connect you with better content, with the content that's out there. And so we do a lot of A/B testing. Now, for those who don't know what A/B testing is, what it means is whenever we get a group of new members to Netflix, what we do is take a certain portion of them and we give them the existing experience. Now, we take another portion and we give them a new feature, a different UI with features in it we think they will find compelling. And based on which one performs better, if the other group performs better, we'll take those new features and integrate them back into the main UI. And that's why over time, we've really improved our UX. And so JavaScript gives us the ability to break out of the App Store model, where our iOS version is just hosting a web view. And so we can still do A/B testing even though we're in an App Store. Same thing applies to some embedded devices with app stores, for example, like televisions. So today we have 3 JavaScript UIs, one for mobile, web, and television, as a matter of fact, where we use JavaScript as well. And that's really, we have these different UIs to really kind of respect the differences of these platforms and how differently you interact with them. Number 2 thing you may not know about Netflix, we have a super secret TV platform. I think I may be the first person outside of Netflix to talk about it, certainly one of the first. And the way it works is that it wasn't always this way actually, back in 2010, we were actually doing something which at the time was pretty advanced, which is we were using WebKit to target embedded devices like TVs. So the way it worked is that we basically wrote our very first television UI, or one of our first television UIs, as a web page, and then we took WebKit and we slammed it inside of a television without a Chrome. And so when you're using, at least 3 years ago, when you were using Netflix on your television, you're really just using a web page. So what the platform looked like was basically just WebKit and then a device interface. And we take this platform and we give it to our partners like Samsung, and they would implement it. And you would sort of download just a regular JavaScript, HTML, CSS, and you would go ahead, and that's how the television platform worked. So here's the thing about TV devices, though. They really cover a huge array of different types of devices. Everything from the next-gen console all the way down to the end of the spectrum, where you've got your cable box, that DVD player you bought in Chinatown for 15 bucks, and nowadays, HDMI keys that are, not very expensive. We're talking maybe under a $50, in some cases $30 price point. So how do we cover one UI? How can it cover and create a compelling experience for all these different devices? Frankly, it's really hard, and it's hard for one simple reason, and I'm glad you guys are sitting down because this is might blow your mind. The DOM's not so fast. And so, we tried to make the DOM work on these platforms. We just couldn't do it. And so that's why we introduced this new platform, Gibbon. How Gibbon works, it's really, we took the stuff that we wanted out of WebKit, we took JavaScript core, and we ditched the stuff we didn't want so much, like the DOM. And so the new platform, Gibbon, was basically our low-level, much simpler rendering API we could use to build user interfaces, but still keep some of the, it was still a persistent mode API. So you had, widget object models, very similar to the DOM interface, but much, much lighter way to use and much, much easier for our partners to implement. One of the issues we had with WebKit was things like accelerated compositing was very, very complex to implement. Different partners would have different rendering bugs. This solved that problem for us. So what does it look like to program user interfaces in this system? Well, it's not that different. So let's take a look at what a simple box in WebKit looks like, and here's just what it looks like in Gibbon. So one nice side effect of this is we also got to ditch the HTML, and we used JSON for our rendering. Here's a slightly more complicated example that has a hierarchy, but not mind-blowing. Definitely the presentation technology you're using is not the most complex and important challenge we face as UI engineers, and some of those big challenges have been talked about today. So I know what you guys are thinking, right? I mean, why would we want to do this when CSS is totally awesome? I can kid CSS. We're old friends. We spent a lot of time vertically aligning stuff. But really what Gibbon is for is we have to understand that when you're programming for televisions, you're programming for a much more constrained platform than you have in the open web. And lots of the defaults you have on the web are wrong for televisions. Like, for example, televisions, same aspect ratio all the time. So you can use things like absolute rendering versus flow rendering, and it makes a lot more sense, and it makes things faster. So here are some of the differences between a DOM object and a Gibbon widget. By default, we use absolute positioning. Instead of all the mini types we have, a Gibbon widget's just sort of a wrapper around a simple rectangle on screen, so we don't need all those different types. We also have like 400 plus properties on a DOM object. I mean, they're huge. When you count the style properties, it just goes on and on. We found we could do most of what we needed for the Netflix application with 25 simple properties. And finally, we avoided some of the big mistakes that they made in the DOM, like having expensive synchronous APIs like get client height, which can cause reflows and pause the main thread. And so when we're marshalling information from the native side back to the managed side, it's always using an async API. And finally, explicit styles. We have no more implicit styles. That was a big performance hit for us in the WebKit days. And so we've decided to only use explicit styles. And as a nice side effect of that, componentization becomes a lot easier. We don't need the virtual DOM. In fact, one of the things about the virtual DOM with web components is so that each component can have its own sort of CSS hierarchy. We kind of sidestep that problem entirely if you just use explicit styles. So what we found was Gibbon was smooth, and WebKit wasn't so smooth, and so we moved towards Gibbon. And nowadays, with you load up your television, you're using our special Gibbon platform, and there's very little WebKit out there nowadays. So another great thing was that we found we could actually take this simple low-level drawing interface. The API for the device was actually so simple. It was very canvas-like. So we could actually make this thing run on canvas. And so we can do our development inside of a browser, take advantage of all those development tools that we're accustomed to, breakpoints, and that type of thing. And so that's kind of what the development story looks like inside of Netflix. So we have 3 JavaScript UIs as of 2013. Mobile, web, and TV. Now, when we did our big Darwin rewrite, our big Gibbon rewrite, we changed the UI. We actually took advantage of all of these new A/B tests that we'd done in the last year and took all of that knowledge and synthesized it and built a very different looking UI that relies a lot on rich media to help you get a better idea of the types of themes in your content. So that big image rotates and sort of gives you like insights into different interesting moments in the media. And so we found we got a massively good response from this new Darwin API, the evolution of all of our A/B test knowledge. And so moving right along, the number three thing you guys may not know about Netflix is that we love React. This is something we haven't really talked about, I think, up until 2 days ago with our opening tech blog post, but we have been using React inside of Netflix for almost a year now. And really, I'm not going to spend a lot of time talking to you about why React's awesome. You guys get it. You've drunk the Kool-Aid. You're here. But it's worth breaking things down into 2 categories. The first, obviously, is simplicity. The light touch with which React touches the DOM, it really makes a tremendous difference, right? Performance, not simplicity. The next situation is simplicity. Simplicity is not just about, developer productivity. Simplicity is a feature. This whole idea of the one-way sort of data flow throughout Flux or as an MVC, that one-way data flow enables us to do things like server-side rendering. And Netflix is absolutely going to be taking advantage of server-side rendering. In fact, is taking advantage of server-side rendering to speed up startup times. And so those are the 2 reasons why Netflix really resonated with React really resonated with our developers. So, starting in 2014, Netflix's year of React, we took the iPad experience and we rewrote it using React. We also took the opportunity to take what we learned from that TV platform rewrite, where rich media, and take that same experience and try and take those things that won in the TV space and bring them to the iPad. There's an A/B test out right now, so if you happen to just sign up for Netflix in the next few days, you may get this experience and check it out. And that turned out extremely well for us. The development team's extremely happy. We rewrote the UI from the ground up on top of React. Then, of course, the web guys followed suit because they got a little jealous and they wanted to see some of those same benefits. So we're actually testing an A/B test in the web right now. Again, we took the opportunity to take all of this, what we learned from these A/B tests and rich media, and integrate it in the web experience. And so you can see these things start to converge. We're starting to see these same themes and things on all of our platforms. We also, React has helped us tremendously because, as you can see, these new UIs actually have a lot of big media. And in fact, you can't see it here, but they have quite a bit of animations. And so React has really helped us with the performance curve on these particular devices. So the TV devs got a little bit jealous also, right? We know about React, and we love React, and we're sort of looking over our shoulder and checking out what the other guys are doing. So we decided to ask ourselves a question. Now, this is 4 or 5 months ago. Why would we use React without the DOM? I mean, because that's the most obvious benefit, I think, when you first see React. It's the performance benefits of just touching the DOM as lightly as you could. And frankly, if we were being totally honest with ourselves, we'd solve the performance benefits involved with the DOM by just ditching it, right? Pretty good way to solve your performance problems. And so when we looked at it really critically, we were asking ourselves, well, does React going to really give us a performance win here? And if anything, it's a layer of abstraction, so it may actually cost us some performance. And so we really have to have a strong incentive to want to use React on this platform. And thankfully, we do, which is the simplicity. Everything we talked about, developer productivity, the one-way data flow, not only makes developers more productive, but it also enables a new scenario, which is really key, really important to us, which is server-side rendering. We want to be able to render markup even for the television on the server and speed up startup. So the next question was, can it be done? Well, now we all know the answer to this question. But at the time, 4 or 5 months ago, React, I think, was 2 minor versions back. I think it was V11 when we took a look at it. And we really weren't sure if we could do it. But sort of implicitly, we told ourselves, well, React diffs trees, right? I mean, and if you diff the DOM tree and make changes to it, Gibbon's got widgets, and it's got a widget tree. Surely we could make the same changes to the widget and see the same benefits. So Netflix gave our developers a challenge. We challenged ourselves. We were like, well, if React's ready, if it's there, if it's kind of like prime time, we should be able to get this done in 5 days. We figured we could build at least a prototype and get it up and going in 5 days. So first, the bad news. The bad news was when we took a look at it, certainly in the V11 timeframe, we needed some access to the internals. There was really no way to get by with just sort of, otherwise we would have had to rewrite a lot of the code that was there in React. And we were really trying to work in the timeline because we had a lot of work to do. We were trying to figure out what the quickest way to get on top of React was. So we could think of 2 strategies to integrate React and Gibbon. The first was, and it's kind of a hammer, but it works, fork. Right? So we took a look at it. We forked React, right? Poor guy. So we wanted to figure out the quickest way to do it. So in order to teach you how this worked, first I'm just going to have to teach you a little bit about how Gibbon works. Long story short, Gibbon takes this JSON markup. It's not a string, just a JSON. And you pass it to Gibbon load. And it takes each one of those little widget objects and it puts it into a regular class, like a regular quote-unquote JavaScript class. Right? And so that is basically using the terrible pattern you were just told about a moment ago, which is dirty checking. So these Gibbon widgets have properties with getters and setters, and they mark when a particular property is changed, and then send that information off to native. We just didn't know any better. We didn't know any better. For the virtual DOM showed us the way. So the problem, of course, is that React targets the DOM and not Gibbon widgets, and not 3JS objects and not WebGL objects and all these other potential view technologies that you could think of. So why don't we just emulate the DOM? Why don't we take all those Gibbon widgets and emulate all of those DOM methods, those interfaces that we know so well? Add event listener, remove event listener. So we figured we would just emulate the DOM, and then we make a little mix-in, stick it into our widget, and all of a sudden, bam, React and Gibbon talk to each other. And it was almost that easy, in fact. So here's what we did. We just put together this little mix-in. You can see sort of set attribute and get attribute because, again, this is just a regular JavaScript object with setters and getters. You can just set those properties. It was not that hard to implement the DOM. We had to implement event bubbling and event capturing as well to make sure that the illusion was complete. So now React can update widgets, but there's still a problem. That approach alone wasn't enough because all the DOM stuff inside of React is designed to emit HTML strings, at least initially. It emits HTML. And we don't need an HTML. We need JSON. So we needed to open it up under the hood, take a look at the internals, and we found there was 2 objects. DOM property operations, which is a set of helper functions for just generating DOM information, and React DOM component, which was one of the mix-ins that was pulled into a React component. So there actually was very, very few places in React where HTML strings were being generated. So there was mount component where you generate a little bit of string like create open tag markup and put listeners, create content markup, so the stuff inside of the HTML. DOM property operations had just one little piece which created markup for a property, so that's an actual attribute, something equals some string. So we took that, forked the heck out of it, and then magically we got our JSON out. And so that allowed us to actually start building components. So here's an example of a simple button component in React Gibbon that allows you to just create a little box with something in there, and whenever you click on it, mouse down, the background color changes, and when you mouse up, the background color changes back. And so now, for those of you who aren't familiar with the changes in 0.12, since we aren't using JSX and we have really no need to when you're working in a JSON platform, we've got to explicitly use React.createFactory. So now in 0.12, when you create a class, it's just a descriptor, and then in order to be able to actually call that method to create them, you need to call createFactory and pass in the output of your create class. So here's an example of me. Oh, by the way, who's familiar with ES6's object.assign? Quite a few hands. Great. So that's basically just doing a mix-in. So object.assign will just take one argument, which is the target, and then a bunch of source arguments, and it'll just take all the stuff in the source arguments, mix them in to the target element, and then just return it. So that's all I'm doing there. I'm doing a mix-in. So React Gibbon integration, it just worked. So that took us not too long. Actually, I think we had a prototype up and working with search and gallery in a very, very short time. And so the total time it took us to do this React fork, 2 days. Number of lines of code we actually had to fork, I think it was only about 67. So we were pretty emboldened. We started now in the process of building our UI actively on top of React. But that said, forking's not a perfect solution, right? And there's some obvious downsides, specifically that React continues to move forward. If you look at the internals of React, there's been a lot of refactoring in the last 2 minor versions. And so if you fork, you kind of get off the train. We'd like to be on the train. And so why not spoon React instead? So what do I mean by spoon React? Well, create a custom build with browserify. Access those private members using require, because there are still a few private members you need to access if you don't want to end up rewriting a lot of code. And then monkey patch any methods that happen to touch the DOM. This didn't actually turn out to be necessary, interestingly enough. So here's some examples in the wild that we could take a look at. Now, React iOS will be in the wild shortly. React Art is a really interesting project. React Art. So there's an Art JavaScript library. Hands up who's familiar with the Art JavaScript library. Couple of people. Who's familiar with Raphael? Anybody heard of Raphael? Quite a few more people. So they're very similar, and the idea is to have a generic drawing API, but then target whatever happens to be available in terms of draw technology. You can target WebGL, and you can target Canvas. If somebody's like on your site with IE4, you can even target like VML. So it's all to hide you from all those technologies and just allow you to draw vector art. So what they've done, and Art was actually forked by Facebook a while back, and they built React Art as their sort of bridge to allow you to target the Art library with React. And we borrowed very, very heavily from the React Art library in this little prototype. So spooning just got a lot easier with React 0.13. The idea is, and I think when I first tried this in 0.12, I needed access to actually 3 internal mix-ins just to get this going. But something happened in React 0.13, which is that a lot of the stuff that React expected to be in the component, that you needed to mix into the component, has actually been moved out, and it's now in React. And so when you call React.mount component, it'll just do that work for you instead of delegating to the component. And that's nice because React components can now be kind of like lightweight. They can just sort of be property bags that you can go and override certain methods that React expects to be there. And we'll take a look at what those methods look like. And as you can see, you're going to see it's pretty straightforward to be able to target any potentially Vue technology nowadays with the methods that they have in place. So The requisite warning, these extensibility points aren't necessarily guaranteed to be there going forward. We're just using the ones that work right now. What I think we can guarantee going forward is that React will be able to target multiple different view targets, as you can see from React Native. This is definitely a goal of theirs. And so that's why Netflix feels confident that we can go forward and implement on top of this sort of React for a totally different display technology than the DOM. So first, let's pull in internal members. Actually, the only one we need nowadays is React multi-child. React multi-child is a mixin that gets pulled inside of the component, and it deals with all of that children stuff around diffing and IDs and that type of stuff. So by pulling that in, we actually get a nice chunk of code that we can reuse. So I'm going to create my component. I'm actually just going to create the one basic component, the atom of our system, which is the widget. And this little create component method just takes in a name, and it takes in a bunch of mix-ins, and then it just sort of mixes them all in. But I'm going to focus on the private members. Node, this is actually what holds on to the object you're targeting. So if this were the DOM, node would be, you could use node to hold on to the HTML node. If this were WebGL, you might hold on to some little JavaScript wrapper that's representing some mesh on screen. Subscriptions keeps track of all the event subscriptions that you've got on a particular widget. Mount image is actually, interestingly enough, very often the exact same thing as this.node, but it's a private member that React multi-child expects to be there, and it's going to populate for us. And so once again, it's the actual real object, like the ref, to your HTML object that the component represents. And rendered children, once again, that's actually populated by React multi-child, some methods when we call it. It's what goes through your child collection and turns all those components into real nodes. And so it's going to be populating that member, so I'm just initializing it here. So I'm going to split this into two mix-ins, not because I have to, but just because it's a little more convenient to talk about. A node mix-in, which handles just property stuff, and then the container mix-in, which just handles all the child stuff. Now, if you look inside React, they really practice what they preach because they use a huge number of mix-ins. There's really not any inheritance to speak of, and so I'm just sort of following suit in my approach here. So first, let's take a look at the node mix-in for property handling. Now, all of these particular methods are called by React. Things like put event listener, handle event, destroy event listeners, and crucially, apply node properties. So Gibbon widget is just relatively straightforward. It just has a property where you store an event handler, and then it invokes it. So adding an event listener is very simple. All I do is I sort of just add it to the list of subscriptions, my this.subscriptions, which I defined earlier, and that'll allow me to sort of remove all the subscriptions when that node gets unmounted. And apply node props. As you can see, I'm just looping through all the new properties and setting them. That's going to end up going through the setter path and updating my widget. Container mix-in for child handling. Now notice here's where we're going to build a mix-in of our own, but we're going to mix in React multi-child mix-in, and I'll show you where we delegate to that in just a moment. But as you can see, implement move child, implement create child, implement remove child. These are all straightforward things you can do for whatever view technology you want to target that happens to have a tree. And then what's going to happen is here inside of mount and inject children, this is where we call React multi-child's mount children method. And it's going to go down through our children collection, create all of our children widgets, and create this little mount. Yeah, there's the rendered children. So it creates this rendered children array. And we can just loop through those rendered children and add them, to our own node's children. So this.node.children.push you see at the bottom there, I'm just looping through, grabbing the mounted image from each one of those rendered children, which again is the real DOM node, it's the ref, and adding it to my own underlying node. So that's not a lot of code, right? I mean, I've abbreviated move child, create child, and but I can assure you most of those code is like 5-6 lines of code. So then all that's left to do is export my public members, React Gibbon widget. And now I can write the exact same code that I wrote before. This time, no forking required. And so once again, that create factory's got to be called. But then I can use it inside of the render method. So as of today, but throughout 2015, I believe, we're going to be continuing to work on our television version of React. And so you're going to start to see all platforms, hopefully in 2015, be on top of React. We're really excited about this ground-up rewrite of all of Netflix's UIs in React. And once again, I just want to emphasize, we love it. Today, we're going to really start talking about it publicly. We released a blog post 2 days ago. It was got a lot of tweets. Netflix likes React. And you can check out our blog post going forward as we're going to talk about our experiences, both extending React to other platforms, but frankly, just making it work in a web view inside of iOS, and so on and so forth. Here are some resources you guys can check out. Check out React. I'm really looking forward to React iOS source code at the end of the day. That's going to be pretty awesome. And are there any questions?
Hi, you just mentioned that you can use Canvas for debugging because for the TV platform. Can you explain, do you actually open source the code that make the React component renderable somehow on
Well, so
HTML
unfortunately,
Canvas?
Gibbon is closed source. We do think of it as a pretty big competitive advantage, and we would like to keep that advantage. However, React Art is a really great place to take a look. If you're interested in this type of extensibility, React Art is a public source, and you check it out. The canvas rendering piece is that we actually can just, because the interface of Gibbon to the device is a very low-level drawing-like interface, it's practically canvas anyways. It was no problem for us to write a little emulator that just ran it against an HTML canvas, and that allows us to run right inside of the browser. Any other questions? Thanks very much, guys.